So in that last video, I introduced you to that concept of a molecular compound. Those polyatomic ions were compounds that had what's known as a covalent bond, and they came from molecules. In this section, we're going to actually look at what a molecular compound is and what it means. So the learning goal is going to be to given the formula of a molecular compound, to write its correct name, and given the name of a molecular compound, write its formula. So first what we're going to do is to see what actually defines a molecule. So molecular compounds form when electrons are shared. So a molecular compound results from atoms of two or more nonmetals, and they're sharing electrons to form what's called a covalent bond. Okay. So in the beginning of this chapter, we were looking at ionic bonds, where you had a sodium and a chlorine, and they were going to be held together by attraction. Particularly electrostatic attraction, because you have a positive charge on the sodium and a negative charge on the chlorine. In order to form this sodium cation, you had neutral sodium and it lost one electron. Instead of losing an electron or gaining an electron, what we're going to do is these valence electrons are going to be shared, and they're going to be shared by non-metal atoms to achieve stability. So again, I just want you to recall, when you had the metals and the non-metals that would either form a cation in the case of a metal and an anion in the case of a non-metal, they were actually losing valence electrons or gaining valence electrons to achieve noble gas configuration, which was stable. Here, we're going to share electrons. And again, it's all going to be driven by the octet rule. So a molecule forms when you have two or more atoms coming together to share electrons, forming a stable compound. Similarly to what we looked at with the ionic compounds, the simplest covalent compounds are binary covalent compounds that are composed of molecules that only have two different types of atoms. To name a binary covalent compound, you identify the name of the element first in the molecular formula, followed by the name of the second element, and change the ending of the second element to "ide." Okay, so again, if we just have a simple binary compound, which is just two elements, the first nonmetal is going to be named by its element name. The second nonmetal, the name is going to be changed by using the first syllable and follow by "ide." When we have more complex compounds that have three or more atoms, we are going to use prefixes. So you're going to insert one of the prefixes given in this table, in table 6.10, before each element's name to indicate the number and type of atom as indicated by the subscript. Right? So when we look at some examples, this will make a little bit more sense. All right, so let's just take that binary compound first. We'll take nitrogen and oxygen. So it's NO. So this would be nitrogen oxide. All right, now instead of just having a single oxygen, we're going to have two oxygens. So this would be nitrogen dioxide. Here you have NO3. This would be nitrogen trioxide. So the number of oxygen atoms is going to be indicated by the prefixes that are listed in table 6.10. In the name of a molecular compound, such as the binary compound, okay, you typically omit the monosyllable. Okay. The exception to this rule is going to be carbon monoxide. Okay. In all other binary compounds, similar to what I wrote above, you omit the mono, except for carbon monoxide. Okay. So table 6.11 lists some common molecular compounds. We have carbon dioxide, which is CO2. Okay. We all exhale carbon dioxide. Carbon dioxide is used by plants to make sugar and oxygen in the process of photosynthesis. You do not have to memorize these common molecular compounds. However, we're going to learn when given the formula how to name them, and when given the name how to write the formula. So here's an example. We have the molecular compound NBr3. So pause the video and write the name for this compound. So it would be nitrogen tribromide. Again, so this is just laying it out in table form. There's one nitrogen, so there's no prefix. There's 3 bromines, so the prefix is tri. It is the second element, so we use the first syllable and change the ending to "ide." And so we have nitrogen tribromide. Here's our learning check. Pause your video and answer the following questions. So we have SiCl4. Si is silicone and Cl is chlorine. So it should be silicone tetrafluoride because there are 4 chlorines. The next compound is we have phosphorus and oxygen. There are 2 phosphoruses, so it's diphosphorus, and there are 5 oxygens, so it's pentoxide. In C, we have 2 chlorines and 7 oxygens, so that is dichlorine heptoxide, or choice 1. Okay, so here are the answers laid out for the previous problems. Here's another learning check. You have to write the name for each molecular compound. Pause your video and write down the names. The first one is carbon monoxide. Again, this is the exception where you use mono. The next one is dinitrogen oxide. Then we have phosphorus trifluoride. And finally, carbon tetrachloride. So this is just going to step us through the process. The first element is the nonmetal. The second nonmetal that we have, we are going to use the first syllable and change the ending to "ide." And then we have to add the prefixes again, so it's carbon monoxide is the exception, the dinitrogen oxide, phosphorus trifluoride, and then finally carbon tetrachloride. So now another learning check. Write the formula for the molecular compound diphosphorus pentoxide. So we should have 2 phosphoruses and 5 oxygens. And you can see that laid out here. Another learning check to practice: phosphorus pentachloride, dinitrogen trioxide, and sulfur hexafluoride. So write the correct formulas for each. We have phosphorus Cl5, we have N2O3, and sulfur, so it's SF6. And so the answers are laid out here. Before we move on to the next segment, I just want to recall the polyatomics. So here when we have PO4 3-, we do not name this phosphate tetraoxide. And the reason is because we have lost electrons to give this a 3 negative charge. That's why this is known as phosphate. But you can see that this is a polyatomic that comes from a molecule because you have 2 nonmetals here. Okay. And so when we look at the bonding a little bit more carefully, we'll see that there are covalent bonds holding together the phosphorus and the 4 oxygens. So the electrons are shared between the phosphorus and the 4 oxygens. Right. So is a compound ionic or molecular? The compound is usually ionic if the first element in the formula is a metal or the polyatomic ion NH4. So here we have K2O. Potassium, K, is a metal. The compound is ionic and is named potassium oxide. If a compound is molecular, the first element in the formula is a nonmetal. So here we have N2O. Nitrogen, N, is a nonmetal. The compound is molecular. It's named dinitrogen oxide. So remember, in our ionic formulas or our ionic compounds, we do not use prefixes. But in the molecular compounds, we do have to include the prefix when we have a subscript. So this table provides a flow chart for naming chemical compounds. So first, we have two types of compounds, ionic and molecular. So remember, ionic compounds, you have a metal and a nonmetal. For molecular compounds, we have two nonmetals. The metal will come first, and it could either be a metal or the ammonium cation. The ammonium cation is the exception. The second compound will be the nonmetal or the anion. Your metal will only form a positive ion, and you're going to use the element name. Or we can use ammonium if it's ammonium. If we have one of the transition metals, we will need to put a Roman numeral to designate the charge. For your nonmetals, you have your monoatomic ions, such as Cl- or O2-, or we can have our polyatomic ions, such as phosphate and sulfate. In a molecular compound, again, you have two nonmetals. Right. For the first nonmetal, you're going to use the element name and indicate any prefix to match the subscript. For the second nonmetal, you will use the first syllable and end with "ide," and be sure to have any prefix to match the subscript. So let's do a learning check. Identify each compound as ionic or molecular and give its correct name. Pause your video and answer the questions. So this first compound is molecular. We have SO3. This is sulfur trioxide. I want to point out it is not sulfite. If it had a charge, then it would be sulfite. The next compound is ionic. We have a metal and a nonmetal. It is barium chloride. Now barium is a group 2A metal, so we do not need to designate the charge in parentheses. Then we have another ionic compound. It is going to be ammonium phosphite. Again, with an ionic compound, we do not need to use prefixes. D is also an ionic compound. We have a metal and a polyatomic. Now, here we have copper, but copper is a transition metal. We have copper carbonate. The charge on carbonate is always 2-, so this is copper 1 carbonate. And then finally, we have a molecular compound because we have two nonmetals, and it is dinitrogen tetraoxide. So that chapter that we did the periodic table in chapter 4, it's really important that we have a good foundation of that chapter. Again, you don't have to have the periodic table memorized, but if we know where the metals are compared to the nonmetals, that will help. If we know where the transition metals are, that will help. If we know what properties are for group 1A and 2A and 7A, like I said, you have to memorize those, then that will just help this process along. Okay, so here are the answers nicely typed out for you.